This is example 2 of finding the inverse of a function. The function this time is y equals x squared plus 1. We're again going to first do it visually and then do it algebraically. To do it visually, notice that we're going from squaring of x and then to adding 1. So squaring x, adding 1. Now to find the inverse, we're going to essentially go backwards and do the reverse. So the first thing we're going to do is subtract 1, and then the second thing we're going to do is we're going to take both the positive and the negative square root. Our next step is to interchange the y and the x and the y. Once we've done that, we can now solve the equation, or simplify the equation by solving for y. Our first step is to subtract 1, and so we're going to subtract 1 from both sides. And then our next step then is going to be to take the positive and the negative square root of x minus 1. And you can see that this matches our diagram where we're first subtracting 1 and then taking the positive and negative square root. Now to verify whether or not this actually is an inverse, what we need to do, or what we should do, is simply graph both the original equation and the equation that we calculated as the inverse and see whether or not they're symmetrical about the y equals x. And as you can see, the orange equation, which is y equals x squared plus 1, is indeed symmetrical to both the positive, the black, and the negative square root of x minus 1, the red one. Y equals x is the line of symmetry, and you can see that point for point there is a symmetry where the x and the y are reversed for both the orange equation and the black and red equation.